Dear participants, welcome back for the next session. अच्छा So in this session, I will be covering hydraulic structures and infrastructure planning, which is the very important topic in master planning. See, in this presentation, it will be around 20-25, maybe up to 30-minute presentation. I will be covering what are the guidelines, standard guidelines for designing, defining, taking approval, the factors should be considered, while designing or considering the planning in the various infrastructures in the river basin. So the content of this presentation would be introduction, background. We already discussed this component. Then basin characteristics again will come in the picture, because whatever you are planning to design or construct, it actually needs evaluation of what is the characteristics of your basin and what is the volume, flow volume, the rainfall characteristics, the topography of the area, then functionality of hydraulic structure. I mean, your objective should be clear. For what purpose you are planning to design or construct any kind of infrastructure for the river basin, and objective then basin data collection. So you should have handy data with you. Most of the data is fairly available, but there are some data which are you need to collect from the departments, relevant agencies. Then hydrological, meteorological assessment of the river basin and demand assessment, water balance studies as we discussed in previous topics. And then approach, identification of infrastructure options, feasibility, design consideration, flood management and safety aspects, environmental impact assessment, which is very mandatory component. You need to take approval from various competent authority if your structure or your infrastructure is impacting the environment or not. So you need to take approval, and then most of these authorities are in the central agencies. Okay, so we'll discuss from which agency you need to take what approval. And climate change resilience assessment. There are Niti Aayog is the agency who is looking after this. Prioritization of the structures, then institutional and implementation framework, then key challenges, issues. Will highlight. We'll touch upon all these points. Then way forward recommendations, and at the last we will see the list of departments, the central agencies. We'll be touching upon all the central agencies from where we need to take the approval for a specific component of the project. Why this is required? The hydraulic structure or infrastructure, why this is required? Your objective should be there. The main objective are regulating the flow, then storing the water, mitigating the floods, providing water resources, water supply to the irrigation, domestic, industrial, then meet the demands, whatever scarcity of the water in which sector you have to plan accordingly. Then earlier days, the infrastructure development was sector specific and fragmented, leading to insufficiency, conflict and environmental impacts, like I have already discussed. It should be integrated component, and there are various stages where you need to take approval from competent authorities, like environmental clearance. Clearance is the major component when you need to take care of all the environmental aspects when you are planning to design a dam or water storage structure, or you are planning to divert the water. Then you should maintain the downstream the availability of the water after your structure once your structure is in place. So we need to consider the environmental flow also, and there are some rules how much flow we should consider for what is your accordingly your basin size and what. Then optimum or optimal water utilization should be there. Then climate resilience. For example, today you are planning to construct a infrastructure and you are not considering the climate change impact, because the moment you are designing, then you are not designing for 1 year or 2 years or 5 years. There are some structures you are designing for 100 years, then 50 years. Then you should consider what will be the climate stress after 50 years, 100 years. All those parameters you should consider while designing this structure. Topography you need to study, physiography, soil condition, land use pattern, social issues, social and resettlement issues. Like if public works department planning to construct a highway, then they are doing pre-feasibility, then feasibility, then approval, then they may face several conflict issues, social settlements, so compensations. So these are the issues. If you are planning to design a larger scale project, then you should consider all these aspects. Otherwise, department level, if you are, your purpose is for small scale structure design, then you need not to consider all those aspects. The topography, elevation, morphology, what is the river morphology condition, then floodplain characteristics, historical flooding scenarios, like you need to see in the previous session we saw that guidelines for setting up any industry, schools, construction activities. There are different types of zones as recommended by National Disaster Management Authority. So you should consider in what area your project location lies and what is your objective. So accordingly you need to take care. You are already might be doing all those things, but still you need to follow some procedures. Then geology, soil condition for designing the soil testing and all you need to take care. Then land use, ecology, social economic factors, sectoral water demands, these things. So these are types of purpose, function, role of your hydraulic structure design. Water storage and regulation, as we discussed in last session. Irrigation, command area development. If you have plenty of water in your basin, and then slope and all these topography is supporting, then you can also plan for a command area development. Then flood modernization, river training. River training we already discussed. If it is feasible for your location, then you can plan this river training work also. Hydropower generation, you can construct a dam, you can construct a multi-purpose dam. But see, this is not so easy task, because once you are planning to do this, then there are a lot of social aspects, environmental aspects. You might be aware about all these ongoing projects like Subansiri Lower and some projects in Arunachal, because it is not so easy to get approval and to satisfy the requirement of all the stakeholders. I'm saying the NGOs, then communities, then public, then politicians, then lot of stages are there. So you need to consider all the aspects while designing all these infrastructure and this project in your basin. Drinking, industrial water supply, the groundwater recharge support, because the spring side management in the northeast, the Meghalaya, that you are planning to recharge facility in your spring, then you should consider these kind of parameters: their availability of rainfall, their slope, and soil, land use type, all these. What kind of vegetation is there? You should consider all those aspects. Objective, of course, you should have the clarity of objectives: ecological balance, hydropower, flood modernization, irrigation, water supply, security, water security. All these aspects you need to take. Then compilation of the existing data for the basins. You need to have long term, because any hydrologic structure or infrastructure, hydraulic structure designing, you need to have a good amount of data. For any hydrological analysis, it is recommended to use at least 30 years of time series data, so that if data more than 30 years period you have, then it's good. Otherwise, at least you should have 30 years of data in the hand, so that you can check the trends, the annual values, then the peaks, then abnormally you can judge what is the trend, and you can also analyze the future data. I mean, what is the projection providing by different agencies. These are the flood records level, then basin slope, river morphology, all these basin characteristics, rock type. If you are constructing a storage structures or the embankment, the levees, then you should have the clarity of what type of soil strata is there. Accordingly, the design will vary. Then inventory of socio-economic data, the population growth, population demand, the livestock trend, then irrigation patterns, cropping patterns, government policies, what changes government is doing in their policies. So all these aspects you should consider. Then GIS based analysis like vector and raster data you should analyze. You should define the parameters. You should have this digital data in hand to analyze the slope. Their satellite imagery also you should consider what kind of pattern you are observing in the land use, and what is the probability of changing the land use in the coming years. So you can estimate a trend from the satellite imageries from NRIC and other agencies which are doing this. Then hydrological modeling, you can, yesterday we discussed how to estimate the water availability in the basin, but while this is good for rough estimation, but you are planning to design a structure there, then you should have, because you are going to invest a huge amount of money there, so you should have the clear and correct picture in hand. So for this purpose, you should have modeling tools, the latest technology in hand, so that you can assess the actual and correct value of the water resources availability for that particular site. Like these are some models you can use. Then rainfall runoff relationship, SWOT, HEC, HMS, MIC you can use. You can identify, you should also identify these flood prone zones, water scarce regions, and then trend of groundwater there, because you should promote the conjunctive use of the water there. If your surface water is going to reduce, then you should use this. You should know what is the availability of groundwater in your area, that so conjunctive use you can make. Groundwater availability you should assess, then surface water availability you should assess, then flood frequency analysis you should perform, because once you collected all the data, after collecting the data, your objective should be, okay, I am planning to design a check dam, so your what would be the return period for which you are planning to design. So there are some methods, flood frequency analysis, there are different methods, so you can consider the time series data, longer duration time series data, at least 30 years, and then you estimate the design flow. Design flow is nothing but the input which will use to design your structure. Like for, if you are planning to design the city level drainage network, then you should have the 2 to 5 year return period data in hand. If planning to design the dam or this culvert or this, then 50 year return period or 100 year return period data you should have, and then your estimation should tell that if I am planning to design a culvert for this particular place to pass on the flood, then you should have at least 50 years return period flood values in hand. And how to estimate the 50 year return period flood value? Then there are some standard methods. This training we have not considered, but we will try to highlight how to estimate the return period flood. Then there are some IDF curve, intensity, duration, frequency analysis. Intensity, the rainfall intensity, duration, how much duration, and then frequency. And it's 5 year, 10 year, 25 years, 50 years. These are some design storm plots. So CWC provides these guidelines. They have some documents, publications where you can use. Even you can use, you already you might be using all those things, but CWC provides the, while you are designing the embankment, the porcupines, the geobags for the particular area, then they are having some standard guidelines. What should be the material, what should be the quantity, what should be the IS code. So I'll let you know the documents, because I cannot discuss each and every documents guidelines, but at the end of this PPT, I will provide the list of the references from where you can access their portal, you can download, and either we can provide you those material, but you should know which agency is responsible for providing this. For example, if you are in this environmental flow, then you should get clearance from Ministry of Environment and Forest. Like if you are constructing any storage structure or dam in your basin, then there is provision to take approval from Central Water Commission. Okay, though this falls under the judiciary of the Central Water Commission. Then these are methods are rational method, SES unit, this curve number method, unit hydrograph. These are the methods to estimate the design flow. There are standard guidelines. We can use modeling tool like HMS. Just after this session, we will be having the hands-on exercise of HMS, so we can use HMS for this design purpose to estimate the flow value. These are some distribution. There are other distribution as well, but commonly in hydrological series, these are distribution the researchers or the agencies are using to estimate the flood frequency analysis. Then what type of structure you are planning to design? Identify the rehabilitation needs for infrastructure gaps in major dams, barrages, canal, irrigation channels, then flood protection embankment, dams, anycuts, urban drainage, stormwater drainage, infrastructure. So for all these components, you are having different sets of guidelines. So I will be touching. Then demand assessment for water balance study, growth estimate, future water demand, considering the climate change impact scenario. Then basin level balance studies, water balance, what is the water potential in your basin. Then identify priorities area. If you have sufficient water, then there should be a plan of diversion of water to the nearby area where there is a scarcity of water. And if there is the water quality issue, then we should plan the water treatment, something like that. So depending upon your priority, your basin area, you should have the priority 1, 2, 3, 4, 5. Like if considering the budget allocation and your characteristic of your basin. So these are few things we need to consider. Almost all idyllic structure design, integrated IRBM, integrated river basin management, IWRM practices you should, and then there should be a sustainable, this requirement for this. Your environment should not affect, then the community, local people should not affect, and your biodiversity, nature should not affect, and other impact you should not be there while designing. Surface and groundwater consumptive use already discussed. There should be a clear plan. If you are going to use the surface water for the different purpose, then you should have plenty of groundwater availability for the particular area, so that you can plan accordingly to fulfill that requirement. Then demand and water supply. Once you have the demand in hand, then what is the supply available for that particular basin. Climate variability, extreme event consideration, climate change models are there. What model is suitable for your area, then you should consider that model. You should put a factor there. Okay, my rainfall would be this, 20% higher or 30% higher in 50 years, after 75 years or 100 years from now. So you should consider all those factors. Then what are the possible interventions while you should consider while designing the new storage, diversion, rehabilitation of the structures. Your rehabilitation plan should also be there. Then canal modernization, automation, flood protection, river training works, recharge, conjunctive recharge. As we discussed, spring set recharge schemes. So considering, because in master plan, what we are going to cover, we are going to cover broad level of this information should be there, but it will vary for basin wise, what depending upon considering the various and topographic challenges of the basins. So all these infrastructure design guidelines will be varying for all the basins. Then feasibility, evaluation, and then idyllic design. These are the feasibility, the idyllic feasibility, geological foundation suitability, sediment, river morphology impacts, Then design flood, considering those methods, design flood methods central water commission provides, then storage capacity of the existing infrastructure, then canal capacities. So, and then operation and maintenance requirement. If your structure needs the operation and maintenance after the design period, so you should also consider all those aspects. Then we have already discussed those structural and non-structural measures, flood control, reservoir spillways, river drainings, embankment, levees, then channel improvements, urban stormwater drainage. Then non-structural measures, as we already discussed in last session, you should have the assessment of all these existing information in your basin. Then environmental and social assessment. This is the important activity while designing or setting up a new project in your basin. Assess the impact of river ecology, aquatic life, the biodiversity, the aquaculture, the flora, fauna. You should consider all the aspects, okay? So because northeast states are rich in biodiversity, so you should maintain all those richness, whatever biodiversity status is there. Assess impacts on environmental flows. As I discussed, you should have some amount of flow you should release regularly to maintain the aquaculture or environmental aspects in the basin or river. Assessment of submergence area and land acquisition requirement, that you are well aware why this is required. You should use some tools to assess. I mean, see, this place I am going to construct a reservoir, what will be the submergence area upstream of that structure. So you can, GIS is the technology, in the GIS you can access, you can put the structure where there, you can put some flow, what is the flow available, then you can assess submergence area upstream of that structure. So you should have the submergence area, and then whatever infrastructure falling within the submergence area, you should have some plans to relocate those infrastructure in the new locations. Because these are some challenges. Develop mitigation and management plan, integration, environmental safeguard, infrastructure. These are some guidelines. Climate resilience assessment, considering the climate change, you should have planned the temperature, rainfall, humidity, droughts, all these aspects you should cover, considering using the climate change models. Then prioritization, water stress reduction, flood risk mitigation, economic and social benefits, environmental sustainability. These are few things we should consider. You should prioritize which sector you would like to give, first rank, second rank, considering your location of your basin and size of your basin. Institutional implementation. See, in this aspect you have to discuss your sister departments, then your departments which are concerned about this planning, like central government agencies. You should have some responsibility. You should inform. You should have some discussions. There are some approval stages are there, so you are aware of those approval stages. There are different guidelines. Each aspects, depending upon type of project, you should have different kind of approval stages. And in the approval stages, like in morning we were discussing, it also limited for the funding. If you're budgeting, what is the size of your budget? It's less than 20 crore, then approval stages are different. If your size, the project is greater than 50 crore, then the stages are different. You should have all this information with you, and then assess all these information, funding, investment strategies, then basin level coordination mechanism among the departments. You should define the mandate for each department, in which state, which department is going to play a role while having the feasibility study as well as the during the implementation stage. Capacity building programs and operational maintenance should also be considered for sustainability of this project. And challenges, aging infrastructure and reduce design performance, because today you are planning to design a structure for 50-year return periods, but depending upon the infrastructure, location, the soil strata, other climatic factors, volume of water being received to the storage structure. So these are some challenges, because in order to have some accurate design, you should have some buffer in mind. So what type of buffer you should consider, that is already there in the design document provided by Central Water Commission. Then sediment induced loss of storage, flood motorization capacity, inadequate flood protection and vulnerable reaches, fragmented project based planning approach. Like in very first session I have discussed, same basin, one agency one is establishing or planning to have some project, the similar nature of project the agency Y is planning to establish there, and then their objective is more or less same considering some variations. So there should be a clear coordination among the agencies in order to avoid the future conflict and challenges. So these are some challenges and the limitation of hydrological and sediment monitoring data. The challenge is always there. I should emphasize here, this is the major challenge in this data collection. I am saying we should have the 30 years of long term data in hand, but this data is never, you will never get this data, continuous data. You have some data gaps and all, some problem like hard copy, scan and even errors in data. So you should have clear mechanism to remove those layers, those outliers, considering some statistical procedures, or you should consider some judgmental procedure, you should discuss with the experts. So this is also a challenge, availability of long-term data, because you cannot use 5 years, 7th year or 10 years data for this design purpose. You should have at least 30 years time series data in hand, and even more than that, even hundreds years of data if your goal is to invest in the big structure or large structure you are planning to design. Then shift towards basin scale integrated infrastructure planning, priority to rehabilitation, this we already discussed. Then social resettlement issues, environmental consideration, then decision support system to strengthening the monitoring. Like in master plan, earlier master plan there was no DSS component, was not there. Now the decision support system is coming, because once we prepared the master plan, we have a printed document, hard copy in hand. After 2 years, 5 years, 10 years, nobody knows where is the document, who has kept and where the document has been kept. So now in the master plan also this DSS component comes in picture. DSS, decision support system, web URL, you will be having a link and you can see what status of the master plans. You will get soft copy and then you can also generate some scenarios there, in the master plan. You can see is there revision is required or not in this master plan. You can see what are the challenges, the master plan while the stage agency are using the master plan. So the monitoring, evaluation, operation, maintenance will be easy if we consider this DSS component. Then for planning purpose also decision support systems will help in this purpose. Then adoption of adaptive and climate resilience design. Hydraulic structure planning is central in the sustainable river management. That is, the basin scale integration. You should consider all the basin stage, safety aspects, environmental consideration and all. Then should be scientifically planned and well maintained infrastructure to ensure long-term water security and food safety. These are, this is the important slide. The major challenge while designing or establishing or setting up a new project in your basin, one is funding. So funding is considering your department and your funding agency. Funding may vary, project to project, but there are few things which are remain same for all the projects. Like for example, planning unit. Which department you are planning something, then planning unit you have to consider the National Water Policy document published by Ministry of Water Resources, Ministry of Jal Shakti, and you should also consider the latest document like NWP. I have mentioned included here 2012, but one participant was saying that it is published in 2022. So though it is under revision and validation, so we should consider all those aspects. So then basin master plan, what we are preparing right now, the guiding document. So which agency is providing those guidelines for this purpose? Central Water Commission is providing the guidelines. 1990 first stage, then 2007 the second guidelines. Now we are preparing the SOP for this. So there were also some gaps in the CWC 2007 guidelines. So we have considered, we have taken care of those gaps, and we tried to fill those gaps in the latest SOP. Then flood management, the State Disaster Management Authority and National Disaster Management Authority, there are some guidelines. Guideline means this NDMA guidelines 2016, 2008, only 10-15 page document is there. Okay, very handy document is there. What it consists, all these figure and facts what I saw, the floodplain zoning, the zone 1, zone 2, zone 3, and what should not built in the zone 1 and what should avoid. These kind of things they have mentioned in the NDMA 2008, they have revised in 2016. So there are small documents you should refer. If your flood management is the key consideration of the designing the document. Then design flood, the Central Water Commission is the agency where they have published document guidelines for design flood. So they have considered all these 2-year return period for what purpose, 25-year return period for what purpose, which structure, so everything, designing which material should consider, which is not, should be your priorities, what are the approval stages, everything has been mentioned in this document. So you should consider this document for design flood estimation. Okay. Then reservoir operation, again Central Water Commission, flood cushion, coordinated basin operation, rule curve. Rule curve is nothing but what will be your regulation of water. If my water level in the storage, in the reservoir storage is this much, then this will be my release. So rule curve, all these things the CWC will guide. Then environmental clearance, the EIA notification, mandatory for dams and other river training works, interbasin water transfer. This is the mandatory. Ministry of Environmental and Forest and Climate Change. So this agency you should get. Then sediment management, again the Central Water Commission is the agency, you should get the approval, and they have guidelines on their portal, you can go and check. This is also mandatory, you should consider. Urban infrastructure, like in the Guwahati, GMDA is the agency, okay, so they are responsible for designing the stormwater drain for the Guwahati city. Then you should refer their manual, Ministry of Housing and Urban Affairs, CPHO manual. You should consider. They have given everything there in the manual for designing the stormwater drain for a city. Okay. Then climate resilience, NDMA and Niti Aayog, the agency, the interstate projects, Ministry of Jal Shakti, again the Central Water Commission for interstate water dispute and all. Even these transboundary area disputes, other countries, other states. So transboundary area disputes, the Ministry of Jal Shakti is the agency which is responsible for this. Then technical appraisal, you all are aware, whatever appraisal, techno-economic appraisal guidelines, you should get the clearance from the Central Water Commission for any project we are planning to do. Then disaster risk reduction, NDMA is the agency, we should get the approval. These are some agency documents, and all these agencies are having their guidelines documents. Okay, so this is how we should consider these factors, and then basin specific recommendation will come in the basin specific this master plan. Now after this presentation, as per plan, the hands-on was the plan, but before that, because in this training session we are considering hydrological and hydraulic modeling the tools, because you should have the clarity, you should do some exercise, you should build a base model by your own so that you can put the data, you can simulate the model, you can get results. So for this purpose we have kept some sessions. So just quickly, maybe in 10-15 minutes I will demonstrate here, what is the hydrological model. Most of them you are already aware of it, but those who are not aware of what is the hydrological model, I will cover what is hydrological model. Again, yesterday my fellow trainers might have informed you that what is digital elevation model. Okay, so this is the topographic model, surface model, and there are various types of models are available, open source models are available. The latest and commonly used model is SRTM, shuttle radar topographical missions, SRTM, with the 30 meter by 30 meter pixel resolution. because this model will be having one elevation value for 30 meter by 30 meter pixel, and from this website you can download this. If you define your coordinate, I mean this will be covering in this tutorial. There are XYZ platform are there from where you can download this model, and projection we already discussed. Now basin delineation, because to start the hydrological model we should have clarity of catchment delineation. You might have seen the map of a basin having number of subcatchments 1, 2, 3, 4, 5, 6 up to 10. How they have delineated the subcatchments. Earlier days the planimeter and ridge line calculation manual process were there, but nowadays within the HMS and within the GIS system, within a single click you can delineate the catchments depending upon their topographic, their length and their hydrological characteristics. So there are few steps here the HMS model takes care in the background. Earlier days the GIS was the platform where we have to use for those watershed delineation, but nowadays this HMS tool consists all these functionalities for the catchment delineation, so we can use those. We should have the input, one input only, which is digital elevation model DEM, which we have downloaded in the previous slide. So it will create the sink. First stage, there are few stages, let me go one by one. What is the filling sinks? The raw model, whatever DEM you have downloaded, they might be having some abnormally, some depressions, so to smoothen that, the option is there, one step is there to filling the sinks, and they fill sinks and filling the gaps wherever this abnormally the elevation is there, so you can fill those using this. Then flow direction is the next. You have number of pixels 35 meter by 35 meter elevation pixels, then considering the elevation, suppose one pixel having the elevation 45 meter, then nearby pixel is having the elevation of 46, 47, and one pixel nearby pixel is having the elevation of 40. So what it will do, flow direction will do, the nearby elevation contribution towards the pixel who is having the elevation of 40 meter, because this is the lower elevation pixel. Likewise, then what will be the outlet, where it will drain that 40 meter elevation pixel, the next downstream, which will have the elevation of 30, 20, 25, 15, like outlet you will get the elevation of 5 meter or 10 meter something. So likewise does this flow direction, it decide the direction of flow from one pixel to another pixel. Then flow accumulation is nothing but the adding of the flows in the each basin. Then stream definition, joining the pixels, defining the stream, this is the stream definition. Nowadays in HMS you are not able to see all those functionalities, but you should know how the catchment relation is performed in the HMS. Then stream segmentation, and then finally after some vector and raster files you will get this file, last file, will get a river network and a subcatchment shape file. Each the subcatchment, each subcatchment is having one river file here. This subcatchment, this river file. Let's say these are 10, 12 subcatchments are there. Now see your hydrological, as I mentioned yesterday, in hydrological characteristic is varying in your basin, and you want to make 20 subcatchments. You are having the information available with you, like land use, land cover change, and rainfall variation, whatever details you are having. So the various information, the hydrological characteristic of the basin you are having with you available. So you can use those catchments, to put those information, and there is a provision to put one single information, one single parameter for one single subcatchment. There is a provision to increase or decrease the level of those subcatchments. If you increase the threshold, your subcatchment will be reduced, 5/4 subcatchments. If you lower the threshold, then you can get more subcatchments depending upon your priorities and your requirement. If you like to estimate a very much correct this runoff volume, then you should get this lower threshold to get the maximum subcatchments. These are options. I mean, the first one is DEM. This is the one basin from Meghalaya, Nonba basin. So the DEM is for Nonba basin. Now you can see there are 9 stages are there. The first 6 stages are the raster file. You already aware what is the raster and what is the vector file. Then last 3 options are the output is vector file, the catchment, drainage line, then adjoining catchment. But your final output is the river network shapefile and one catchment shapefile. Coming to HMS, this is how to delineate the catchment in HMS. These are the some steps. Project setup, basin processing. Will take you all these steps while we are performing the hands-on. Okay. So these are the stages, the basin processing, parameter estimation. You need to put parameters for each subcatchment. Okay, different type of parameters, curve number, their loss information. How you should put, we'll let you know in the hands-on session. Then once you develop your model, this is your base model. This is how this looks like. What is it? These symbols are, the nomenclature is given there. This symbol, first one, the diversion. If you have any diversion in your basin, you should put this diversion symbol there, so that you can divert the water from there to another basin or another sink or wherever you want to divert. Then junction is there when 2 tributaries are joining and where the tributaries are meeting, so you should put a junction there. The reservoir in your basin, if the reservoir is there, you should put reservoir. Reservoir property should also be put there. Then sink, source means you are receiving the transboundary data from upstream catchment, then you should put the source data mapper, so that directly you can put the source data. Then subbasin symbol is there. These are the reads, subbasin, source, sink. This definition is given here. So manual also will let you know where is the manual. So manual will provide. So these are the sub elements we use in the HMS, and their description is given here. What are those elements we should consider? This is start new project, how to create the new model. This is has been given. You open the HMS, the window will look like this. This will the desktop. Well, all the elements will be displayed here. This is the watershed explorer. You can click one by one, then you can go to the one element. This is data portal. Where you put rainfall, discharge, water level, all those data. And this is message log. Message log where you are simulating the model. If you are any error in the data, then it will reflect the error here. If your model is successful simulated, then you should get the message here. The message box is there. So this is basic of hydrological model. Basin model, there are 3-4 types of modules are there for putting the data: basin model, meteorological model, control specification, and time series data. And these modules will be listed here, this place. Like Nonba name is there. This is basically basin model. So all these modules will be displayed here in this watershed explorer. Likewise, this, the W700 means your watershed W700. So the moment you click the watershed, it will take you to the particular subbasin. And here is the data in the area. You can see here in the table below, there is an option to put the basin information like basin area, downstream, which methods, latitude, longitude, what is the methods you are adopting in your HMS model. And after putting all the parameter, and these are some methods: initial abstraction, IA 0.2, S is maximum retention potential. If you, because you all are engineer, you have studied, you might have studied this Subramaniam hydrology book. So hydrology basic concept, there are some methods are there, empirical formulas are there. Curve number formula is given here. Okay, so and then Kirpich's formula for estimating the time of concentration. If your rainfall location is here, your rainfall is falling somewhere here in your catchment, and you are estimating your runoff here somewhere here, then what will be the travel time of water runoff peak to reach to up to here, that downstream location. So how much time it will take, you should calculate via using this Kirpich's formula, which consider the length as well as the slope. TC you will calculate in minutes and you can convert in the hours and all. Then storage coefficient, it's required, and some routing functions are there. Basin you have to put some other parameter, then for reach you have to put other parameters. What is basin, what is reach, you will come to know. Finally, after putting all those parameters, here I have put this rainfall time. It's the hyetograph of precipitation versus time. So I put some hyetograph here as input, and after simulating the model, you have to prepare a simulation run, and once you prepare the simulation run, you simulate the model and you get this result. This is the output of this hydrological model. Input is rainfall, and there are some parameters to estimate the losses to the rainfall. As I mentioned, if you are having 100 mm of rainfall in your catchment, the entire rainfall will not be going to convert in the runoff. So there are some losses. As I mentioned yesterday, the forest area, your losses will be higher. The paving area, city, whatever rainfall is falling, maximum of it, maybe 90%, 95% will going to convert into runoff. So these kind of parameters we need to put in the model, and after simulating the model, you will get this discharge. This is the discharge flow, Qmax versus your time. Hydrograph is there, and you will get this hydrograph for all the elements. Wherever you are having the junction, basin, whatever elements you are showing in this map, you will get your hydrograph on all the elements. Okay, upper catchments you will be getting lesser amount of magnitude the hydrograph, and then final outlet you will get sum of all those sum of flow from all the elements. So likewise, this is the basic of all the hydrological model. Now after having a maybe 10-15 minutes break, okay, and then we'll have the demonstration of HMS, which is the open source hydrological model. Okay, thank you very much for your time.